Hello friends, in today's question, a man pushes a cylinder of mass m1 with the help of plank of mass m2 as shown. There is no slipping at any contact. The horizontal component of the force applied by the man is F. Find the acceleration of the plank and the center of mass of the cylinder and the magnitude and direction of the frictional forces at the contact points rather. So this is a cylinder having a mass m1 and a plank which is touching a point of contact is the highest point of the cylinder, and force F is being applied on the plank whose mass is given as m2. There is no slipping, and we have to find out acceleration of plank as well as the cylinder, center of mass, as well as direction of the frictional forces at the point of contact. So we can draw the figure separately, something like this. So this is a plank. A force F is being applied on it. Its mass is given as m2, and we have a cylinder which is on a surface, and the force F is being applied on the m2, and we say that there is a, you can say, plank is m2, yeah. So therefore let us assume that cylinder is given as mass m1 and plank is of mass m2, and because of the frictional force the cylinder and the plank, let us suppose that is given as f2, and between the m1 and the ground that is suppose f1, and which will be acting also in this direction, and because of action reaction between your plank and the cylinder there will be f2 which will be acting in the opposite direction. Let us suppose that is given as in this way, and we also assume that the plank is having an acceleration of a2 and center of mass of the cylinder is having an acceleration of a1, and the both the forces, frictional forces f1 and f2, are acting in the same direction, and therefore we can write the equation for the motion. We can see that later on, and we assume that the angular acceleration of the cylinder is alpha, which is in this direction. So these are the basic things which are acting on it. So therefore let us say this is f2 and this is f1. Okay, yeah. So first of all, let's find out the acceleration of the plank and for the center of mass of the cylinder. Acceleration of the plank and center of mass of cylinder. So now the forces which will be acting on the plank, forces acting on plank. So we have two forces, one is the applied and another one is the frictional force. So let me draw the figure here once again. So this is a plank, mass is given as m2, moving with the acceleration of a2, applied force is F, and we have frictional force which is given as, let us suppose, is F1. So force is acting on the plank is applied force, which is F, and second is the frictional force, that is given as F1, and we said that A2 is acceleration So you can write that for A2 be the acceleration of Planck, we get F minus F1 will be equal to m2 multiplied by A2. F minus F1 is equal to m2 multiplied by A2, and this is our one of the equation which we are going to use later on. Then we find out the forces which are acting on the cylinder. Forces acting on cylinder. So we have two frictional forces. Two frictional forces. First is between the cylinder and the Planck. Between cylinder and Planck, and that is our F1. And the second one is between the cylinder and the surface, ground rather. Second is between cylinder and ground, and that is equal to F2. And both are acting in the same direction. Both frictional forces are acting in same direction, and for center of mass acceleration as A1, you can say for center of mass acceleration A1, we can write the equation as F1 plus F2 is equal to m1 multiplied by A1. This is another equation. Now it is said that there is no slipping between any of the contacts. Okay. So you can say no slipping, and therefore for alpha is the angular acceleration of the cylinder, for alpha be the angular acceleration of cylinder, then we can write equation that for rolling motion, for rolling condition, when cylinder is in contact with the ground, rolling condition between cylinder and ground. So we can write the relationship as A1 is equal to R multiply alpha, where R is the radius of the cylinder. Okay. So we have this is R, radius of the cylinder, and also there is a point of contact point between the Planck as well as your cylinder. So you can say at point of contact between Planck and cylinder, Planck and cylinder for no slipping, there should be no relative acceleration between the plank and the cylinder, or we can say the relative acceleration between the plank and the cylinder should be 0. The relative acceleration between plank and cylinder should be 0, or we can say the acceleration of the topmost point, this point, will be A2, okay, and that A2 will be equal to A1 plus your R into alpha, okay, will be equal to R into alpha. So therefore we can say, thus the acceleration of highest point of cylinder will be A2, and which will be equal to A1 plus R into alpha, and R into alpha is our A1. So from here we can write that A2 will be equal to A1 plus A1, and which gives us A2 is equal to twice of A1. So we found out the relationship between the acceleration of the plank and A1, that is the acceleration of the center of mass. Next, we are going to use the torque equation for the cylinder and solve it further. Torque equation of the cylinder. So we have two forces which are acting on the cylinder, F1 and F2, and they are going to produce the torque in the opposite direction. One will be clockwise and another one will be anti-clockwise. So we can say that torque due to forces F1 and F2, you can write this as F1R minus F2R will be equal to I into alpha, where I is the moment of inertia of the cylinder, and this I will be given as half m1 r square. And we already know that its angular acceleration alpha is equal to a1 upon r. So we are going to substitute these values. So taking r as common from our this part, on the left side get r f1 minus f2 is equal to substituting value of I, that is half m1 r square, and we get a1 into r. This r square and this cancels out, so we get f1 minus f2 is equal to half m1 a1, and we have already derived an equation that says that f1 plus f2 is equal to m1 a1. Okay, so we know f1 plus f2 is equal to m1 a1, and if we add these equations, f2 cancels out, so we get this as 2f1 is equal to, this will be 3 by 2 m1 a1, or we can say f1 is equal to 3 by 4 m1 a1. So we derived one of the relation, that is your frictional force in terms of the a1. A1 was the acceleration of the center of mass of the cylinder. Now we are going to substitute it in this equation and find out our f2. So we can say we get f1 minus f2 is equal to half m1 a1 Substituting F1, we get 3 by 4 m1a1 minus F2 is equal to half m1a1, or we can say our F2 will be equal to 3 by 4 minus 1 by 2, and we get m1a1. So this means F2 is equal to 1 by 4 m1a1. So once again we found out the relationship between the frictional force 2 and the center of mass acceleration a1. Now we are going to find out the relationship with respect to applied force F, and we already know the relationship that F minus F1 is equal to m2a2. Okay. We say but F minus F1 is equal to m2a2, substituting value of a2, and also we know that a2 is equal to twice of a1. So using all these relationship, we can say that our F minus 3 by 4 m1a1 is equal to, we get this as m2 and twice a1. Taking a1 to your right side, we get F is equal to, taking a1 as common, we are left with 3 by 4 m1, and we are left with this twice m2. Now taking as LCM, this becomes a1, we have 3m1 plus 8m2 divided by 4. So from here we can find out our a1 in terms of applied force F. So we get a1 is equal to 4 times F divided by 3m1 plus 8m2. So this is the acceleration of the center of mass. You can say this is acceleration of center of mass of cylinder. Now we can find out a2, because we already know the relationship between a1 and a2. So we know that a2 is equal to twice of a1, so this becomes twice, and we have here 8 f divided by, sorry, this was 4f, not 8, 4f, and we have here 3m1 and plus 8m2. Therefore we get a2 is equal to 8f divided by 3m1 plus 8m2. So this is the acceleration of the Planck, a2. This is acceleration of Planck. Now we come to the frictional forces at the contact point. There are two frictional forces, F1 and F2, because there are two contact points. We say frictional forces at contact points. So we already know that F1 is equal to 3 by 4 m1a1. Substituting value of a1, we get 3 by 4 m1, and this comes as 4f and divided by 3m1 plus 8m2. This 4 goes with the 4, so we get F1 is equal to 3fm1 divided by 3m1 plus 8m2. So this is the frictional force at contact point, that is between the Planck and the cylinder. This is frictional force at contact point cylinder and plank. Now we find out our F2. We know that F2 is equal to 1 by 4 m1a1. F2 is equal to 1 by 4 m1a1. So substituting value of a1, we get 1 by 4 m1, and a1 is our 4f, divided by 3m1 plus 8m2. 4 goes with 4, so we get F2 is equal to m1f divided by 3m1 plus 8m2. So this is the frictional force between the cylinder and the ground. This is frictional force at contact point, cylinder and ground. Okay, so we've solved both A and B part. So this completes the question. Thank you.